Hello all, so welcome back and let us continue our discussion with the question which I given to all of you in the last class, that was, can a function call itself as well? So now let us understand that and do it directly in the code. So this is some code which we saw and wrote the last time, right? To print the numbers from 5 to 1. What I effectively want you to do is, instead of calling or using all these functions, can I do something like this? Where I will be using this printnum function only, and this printnum function is basically gonna do all the thing which all of these my four functions were doing, right? The reason for that is because I'm writing the same code in all of these functions. I want to somehow make sure that I'm able to use the code. Plus at every step, you're gonna see that my problem is actually getting smaller. So I start with printing 5, then 4, then 3, and I effectively have to stop in the end at, I would say, 1, right? So now for the timing, let me just remove all these codes, remove all these functions, and now try to use this way, in this way where I'm calling this functions from within itself, so that it will help us to answer, can a function call itself as well or not, right? So now let me run this code. Okay, so something would happen, like we saw that the code ran, like there is no error or anything like such. In the below, we see that some 991, there is some error, and the error says maximum recursion depth while calling a Python object. Okay, so we'll come back to this error, but first let us try to understand what exactly would have happened, right? So we see that, from 5, 4, 3 to 1, it did get printed, but after that even 0, -1, -2, and all the way till 999, some things are getting printed, right? So let us understand what exactly happens. But first, I think we did get answer to our question. So I think that's a good time. We can write that yes, we can in fact call a function from within a function, or a function can actually call itself, right? So glad that we got this thing answered. Okay, so now I would like to also explain you a little bit concept about the stack memory. So what happens, right? What happens exactly is that whenever a program starts in C, Java, and these languages, and Python is also actually written in top of C language, they all start with a stack memory, right? So they take a stack memory with them, and they basically start with them. And as you keep on defining, I would say, variables, functions, any objects, all of these things kind of get defined in this particular memory. Now at some point it might happen that if you have written a faulty code, or normally if you're trying to actually let's say load something which is more than this memory, then of course this memory can overflow, and hence we get an error of stack overflow, right? So a very popular website, and this is where I would say the major idea or this website came into picture. So stack overflow, like this is a very common error which we used to face, wherein let's say our memory, which the function has kind of picked up when it started, this memory used to get filled, okay, maybe because of some faulty code, or if we are trying to load something, I would say a lot heavy. You can think of it in a very intuitive way. Let's say in your 512 GB computer, you are trying to load a 1 GB file, right? Of course, it cannot load that, and it's gonna give you an error. Okay, so the same thing is actually kind of happening here. The same thing is happening here, where what happened is that Python sets a limit. If you will feel, first let us see that, okay, what exactly happened here, right? So it did print it in 53421, but it didn't know where to stop, right? It didn't know where to stop. So what would have happened here? What would have actually happened here is something like this. We would have called this printnum function. This printnum function would have gotten a value as 5. It printed this 5. It actually printed this 5, which we can see here. And post that it called for 4. Now this function is still actually waiting at line number 3 of its instance, and another instance of printnum is created. These both instances are actually independent of each other, right? So I called a function, yes, from within it, but in a way what happened was that a new instance of this function was created, where the value of num is now 4. Now in a similar way, this 4 would also be printing your number as 4, and then it's going to move forward and call another function for 3. Now again, this is also very much independent. The code is still waiting at line 3 for this 4 function, and this chain is going to get repeated. So for num2, num1, the problem happens at num1. The thing is that in our previous code which we wrote, if you all remember, we didn't call any function after that, right? But here we have not handled that case. Like effectively what is happening is that again this print num is getting called. So this num actually went a step ahead and called for 0, -1, -2, and something like this happened, and they all basically kept on printing these things, right? So now if I see the error, if I show you the error as well, what it is saying is that recursion depth exceeded by calling a Python object. So it's actually using this word recursion. So I will be quickly introducing you this concept of recursion again as well. But somewhere what has happened is that Python started off with some recursion depth, okay, post which it cannot go. And that depth has overall exceeded, and that is done to avoid, I would say, overflow in the stack memory. Because if you will actually understand that all these functions, right, when they are getting created, they are not getting destroyed because they are still in the memory waiting for their next function to complete the work. Like 5, the printnum function with value 5 is still waiting for printnum function with value 4. The 4 one is waiting on 3, and all of them are taking some memory in my computer, right? So that stack memory, it can quickly get filled because it's an infinite call where each and every number is calling for a number less than 1, right? So let us quickly see this again as well, so that your understanding is a lot clear. Now if I show you this, exactly see what's happening, right? So printnum got defined, then I call printnum, it will print the value at this num 5, but now it is calling printnum again with a value less than 1, which is 4, and another instance got created, but this one is still in the memory, right? In a very similar way, print 4, see now, print 4 is actually starting the overall, I would say, working from the top of this function, and it will print 4, and then it's going to call for 3. 3 is going to do it work basically majorly again, and then call for 2. And in a similar way, at 1 as well, though we should have stopped, because in our last code as well, we didn't call any function, right? So we have to somehow make sure that we are able to stop this flow of calling for 0. But because we have not stopped as of now, this kept on just calling, and we are seeing the same thing. Stop, since stack has 30 function on it, your code may have infinite recursion, right? So now what is exactly happening is that, okay, this will keep on going and we are going to see the numbers. But you see, right, all these all these functions, they are still in the memory. They have not actually got destroyed. They are still waiting at their respective line 3 that, hey, the next function is going to complete its work, and then I'm going to get, I'm going to get over with it, and then I'm going to return, right? But because this is not happening, they are still waiting in the memory and they are taking up some space. So now, with that, I hope it is clear that yes, a function can very well call itself, and we should actually also make sure that we fix this thing, right? So how we can do that is in a very similar way, the way we wrote this code. So in the very first code, we wrote this, right? We have not called any function here. So using similar thing, what we can do is if our number is equal to 1, we can return from here. We don't have to actually then call the next function. And now if I run this code, I'm able to see 5, 4, 3, 2, 1 and hello world as well, right? Again, I will repeat what I have done. When the number is equals to 1, I am asking this function to return specifically. Okay, don't call for the next function in your line. Don't call for 0. You just return. And we are effectively able to do the same thing, which in the last class we did with so many functions. The beauty of this code is that even if you have 10 now, you don't need to make these calls, right? You don't need to make this 4, 5, 3 or 6, 7, 8, these functions. You can use the same functions and effectively just print these numbers from 10 to 1, right? So this is something which this overall helps us to do, and we are also able to use the principle of dry where we are not repeating our code. Now if I just quickly show you the working of this code as well, you will see exactly how the method or how all these functions are getting created and then getting destroyed, right? So see, first of all, print num get into the memory, print num with value 5. Then it's going to print the value of number, which is 5. It's going to check, hey number, are you 1? It is going to say no. So it's going to go to the next line and call for 4. Now this 5 is still waiting. It's still waiting at this 5th line. Okay, so you will see that the green line is just that executed and next line getting executed, right? So this is, yes, this is following a cycle. And this overall if condition help us to break this cycle. Now, number 4 is going to get printed. It's going to ask, hey number, are you 1? It's not, so it's going to return, not going to return and call for 3. In a similar way, everything is going to get printed till we call for 1. Where basically we call this print number value with a value of 1. When this happens, we are going to print 1, but this time because this if condition is true, we are going to go inside this if condition. When we go inside this if condition, we are going to just return, right? And we are not going to call for this function. Now, when we return from here, it was print number with a value of 2 which called us, right? So it is waiting in the memory. It is still waiting in the memory, and all the functions rather are waiting in the memory. It's going to get called. Print number 2 is basically the code flow is going to get returned to print number 2, right? So see, 1 is gonna get destroyed because it works has completed now. Once the function completes its work, it gets destroyed, and then we go forward. And you are gonna see that okay, print num2, because it has also gotten its answer, the flow has completed, it's gonna get return none and it's gonna get destroyed. In a very similar way, 3 is gonna get destroyed, 4 is gonna get destroyed, and finally 5 also, the whole flow is completed, it's gonna get destroyed, and we are gonna return to this next line, the line number 11, and we are gonna print hello world, right? So this is the overall exact flow which is happening here when we have called this function from within, and when we have also tried to basically make sure that we are able to stop this flow. Very similar to what we were doing here, but yes, this is a very smart way of writing it. Might be feeling a little weird that yes, a function is calling itself from within, but yeah, that is very well possible in the programming languages. So now let us, I would say, just quickly write what are all learnings from this exercise, because they are going to help us a lot. So with this exercise, okay, so with this exercise, two things are very, very clear to us, right? Two things are clear. So let me write these two things because you should remember them, and that's going to make your understanding a lot more, I would say, easy. The very first one is that functions actually wait in the memory. Functions wait in the memory till or unless they are resolved. So my number, print num 5, 4, 3, all of them were waiting, and print num with value of num 5 and everything, they were waiting in the memory, right? So they wait in the memory till everything is basically not resolved. So they are waiting in the memory till they are resolved. And the next learning is that when a function finishes execution, right? So when a function finishes execution, then only it comes out of program and gets deleted from our stack and gets deleted from our stack. So that's after when our stack memory gets clear, right? So these are all very, very important learning. Now let us see exactly few more things. So now I think we are good to just, I am good to define what exactly recursion is. So many places, and like normally we say that recursion is a function calling itself. So we have written codes where print num, we were calling print num 4 from this function. Like first we saw that, but then we also saw that how our print num function can very well call the print num again. And that is what you can think of recursion. Though there is one more definition which I like you to think on, I would say, and which I want you to remember for recursion, and which is the main thing which will help you to solve lots of questions. That is that recursion is when solution of my problem or solution of a problem depends on same smaller problem. Now if you will see, we have to print 5 and printing 4, right? It was the same problem, right? We just had to print 4 and it is a smaller problem of print 5. In a similar way, 3 was a smaller problem of print 4. So effectively what is happening is that from 5, it is the exact same problem. The code is exactly the same, then 3, then 2, and then 1, right? So all of these are just a same problem, but they are smaller than the previous one, right? So they are using the same code, same logic, and overall I am moving towards, I would say, overall convergence, where let's say my code is gonna get stopped, which is 1 in this case. So this is exactly how we have to remember recursion. That recursion is when solution of a problem depends on the same smaller problem. Now we are good. I hope this all exercises help you to understand a lot better on how function works. Now we are good to start an understanding recursion with the example or use case of a factorial of a number, right? So this understanding of what we have done in this and the last class is gonna now make your recursion journey a lot easy. So in the next class, I'm gonna now discuss and explain you a lot more in depth that how exactly can we solve this code of writing or finding out factorial of a number with the help of a recursion. And you will see that how awesome is it, and all these things which we have learned in this particular I would say class, how that is helping us to actually understand what happens behind the scene when you write a recursive code for finding factorial of a number. So let's meet in the next class, everyone. Thank you.